Good morning, geometry class. Happy Monday. I hope you had a restful weekend. We're going to pick up with chapter 10 and section 3, applying properties of chords. If you remember, I think it was March 12th, Mr. Romano taught you a lesson about tangents, secants, and chords. And just to refresh your memory, a chord is a segment whose endpoints are on a circle. So if we look at this, we see that we have arc RS, right? And it's the arc of the chord RS. So RS is our chord. Just to refresh your memory. We have lots of theorems today. I know you're excited. And remember, I know some of you will want to memorize the numbers, but it's most important that you know what the theorems mean. For theorem 10.3, in the same circle or congruent circles, now if you notice too in my picture I added these segments, two minor arcs are congruent if and only if their corresponding chords are congruent. So that's exactly how I marked it in this diagram. So if AB is congruent to CD, then their arcs must also be congruent. And here's just a reminder too, a major arc is larger than 180, minor less than 180, and the diameter goes through the center and creates a semicircle. Okay. Next page, you're also going to have to draw these segments in. So if I have that y is the midpoint of arc xz, if I know that these two, and I marked them up here, if I know that this xy is congruent to yz, then their angles must be congruent. And if I drew a segment, or the two chords from xy to yz, I also know that they are congruent. Okay, we can say that angles are congruent. And their chords are congruent. And just a refresher, any line segment array that contains y would bisect the arc xz. Theorem 10.4. And again, drawing these segments helps you visualize. If one chord is a perpendicular bisector, of another chord, then the first chord is the diameter. So if I know that it's 90 degrees and it bisects, then this must be the diameter. It goes through the center. I know this. Theorem 10.5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So it would bisect the arc too. All right, moving right along here. Theorem 10.6. And again, I drew in, so you might want to draw in these segments. Says, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay. So I drew in these two chords, and I'm marking that they're equidistant from the center. So that means that AB must be congruent to CD. All right, let's look at some pictures and see what we can conclude. What can you conclude about the diagram? Okay, well, I have that these two chords are marked congruent. So that must mean that their arcs are congruent. Okay. And the theorem that best describes this would be theorem 10.3. And that was the one that says in the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. For the next one. All right, so I know that this is 140 degrees and this is 140 degrees. So that means that this chord is congruent to that chord. So it'd say AB, oh no, sorry, AB is congruent to CB. And it's also because of theorem 10.3, because theorem 10.3 was biconditional. For number 3, I can say that this segment is congruent to this segment because I see this as a diameter and it's perpendicular. I can also say that this arc is congruent to that arc. And this is because of theorem 10.4. Right, so I would say that AD is congruent to DB. And if I had a measure, or I could put in a letter here, but I could also say these two arcs are congruent. All right, let's apply it, and we're going to use our special right triangles and Pythagorean triples to help us out. So it's telling us that O is the center of each circle in the following problems. All right, I see that this is diameter, it's perpendicular. If this is 15, this must be 15, right? So RT must be 30. How do I find OM? Well, this must be a right triangle. So I'm going to use the Pythagorean theorem. Now, I can recognize that this is one of our Pythagorean triples. If this is 15, this is 17, this must be 8. And of course, if you didn't remember that, you could use the Pythagorean theorem. All right, down here, I know that this is 220 degrees. I see if this is the center, this must be the radius. It's perpendicular, which means that this would be congruent to that, this congruent to that. So AB is 360 minus 220 degrees, which is 140 degrees. If these two are congruent, this must be 70 degrees, and this is 70 degrees. So the mark of AC, or the measure of arc AC, yep, is 70 degrees. Measure of angle AOC. Well, it's a central angle, so if the arc is 70, the angle must be 70. All right, page 5. All right, find the measure of arc CD. Well, clearly it's marked that these two are equidistant from the center. So these chords must be congruent. And if these chords are congruent, then their arcs are congruent. So the measure of arc CD, 80 degrees. All right, it's time to draw with Mrs. Kane. Let's see how it goes. Draw a circle O with radius 12 centimeters and chord RS 6 centimeters from O. How long is the chord? All right, not too bad. So here's circle O. I'm going to draw a chord RS 6 centimeters from O. And if I wanted to, I could measure it out to make sure it's exactly 6 centimeters. But we're just going to mark it. Remember, it's always how it's marked. Okay. So this is 6 centimeters. All right, we're going to say it's the perpendicular bisector. And I'm going to draw. All right, so this is chord RS. And I know that this is the radius because it goes from the center to S here. Okay. I'm going to use the Pythagorean theorem, but I don't have to because if you recognize the pattern, this is my leg is 6 centimeters and here is my leg of 12 centimeters. So this is double that. So I know it's not marked if I had actually measured it out, but this should be my shorter leg. So this is a 30, 60, 90 triangle. So this must be the 6 square root of 3, right? Because if this is 6 and that's double, that's 6 square root of 3. This must also be 6 square root of 3. Right? So RS, if I double 6 square root of 3, it's 12 square root of 3. Now, if you didn't recognize it, especially with my drawing, because it's not to scale, you could always do Pythagorean theorem, you'd get the same answer. Next page. All right, if you want to pause the video here and then come back and check your answers, that would be great. So you know if you understand it or not. 360 minus 240 gives me 120. So each one of these must be 60 degrees. So the measure of M and N is 60. For 5, if these two arcs are congruent, and this is 135, this must be 135. So I do 360 minus 270, 90 degrees for MN. For number 6, right, I know these two are congruent, so I'm going to add these two angles together. So 85 plus 65 is 150. I only want half of that. So MN is 75 degrees. For number 7, if these two are congruent, then the angles are congruent, which means this must be 130. So that's 260. 360 minus 260 gives me 100, and that's all I need for the whole arc. There you go. All right, if you have any questions, come see me at Google Chat or send me an email. I'm going to save the proof at the bottom for tomorrow. I know, get excited. Today, what you should do with the rest of your time is page 657, numbers 3 through 17, and you only have to do the odds. I'm probably going to hold a Google Meet on Wednesday. We are going to have a quiz on Thursday, so we just want to talk to you a little bit about what that's going to look like. I hope you're doing well, and I'll see you tomorrow.